We are here to discuss EGMO 2020, namely European Girls Mathematics Olympiad, which has held in most probably in Netherlands. Here is the view of the problem number 2 of the question paper. Find all list x1, x2 up to x2020 of non-negative real numbers such that the following condition hold. First condition, this list is strictly increasing, which means x1 less than, not strictly, it is increasing, x1 less than equals to x2 less than equals to up to x2020. Second condition, x2020 is less than x1 plus 1. And the third condition is there is a permutation x1 x2 up to x2020 of x1 x2 x2020 such that this condition hold. Now let me describe what is a permutation. For example, if we take a set, namely 1 2 3 4, then its permutation it will be its permutation 2 1 3 4. This set is also its permutation. Okay, now here is given some properties of permutation in the last of the question. Let me choose a color. A permutation of list is a list of same length. Same length means if we have, as previous, you can see we have set 1 2 3 4. Okay, it is not actually so said, but I can represent for this for some while in for some intents. Now it is given that 1 2 3 4 is a same is some list, and its permutation will be something which contains 1 2 3 4, but it have same length. Okay, and all the entries are allowed to be any order, as I have shown in the previous example. And here is also a given this example. So let's go ahead to the problem solution. At first of our solution, we should consider some permutations like pi is a permutation of x1 x2 up to x2020, which sends it to a new permutation of x1 x2 in this manner y2020. Okay, now here is some sign which I should like to define. Namely, suppose we have a set, not necessarily set, x is some permutation, okay, of x1 x2, and it is up to x2020. Okay, now I define pi of x as if x belongs to x, then pi x would be belongs to the permutation as I have mentioned here, which means if I take pi of xi, it should give us yy. Now here is something which must be notified at first, that is, look at this thing, pi of xi minus xi. I take mod of this, means the difference of the number and its permutation. Since we take the positive terms, that is why I take the mod of these things. And note that this is obviously less than difference between pi of xi and x2020. Why? Because x2020 can be the largest of the permutation x1 x2 and x2020. Okay, and hence there is a given condition in the problem. Let me show you that this definitely holds. This means for any xi we can write x 2020 minus xi should be less than or equals to 1. Okay, that is why I am going to write this less than equals to 1. So we get permutation of any integer x, not necessarily integer x, that belongs to the set x as I have mentioned here, and x is less than or equals to 1. This should be an interesting, not necessarily interesting, but it is very important result for this problem at least. Now I am interested to look into something which may easy this problem. Okay, let's see. If we set x1 square plus pi of x1 square plus 1. Oh, I have made a mistake. x1 to the power square. Okay. Now this can be written as below: x pi x plus pi x plus 1 square. Now note that it is greater than equals to x times pi x plus x plus pi x plus pi x minus x whole square. Let me highlight these things. Now why this is true? Because I have previously proved that pi of x minus x and its absolute value is less than equals to 1. That is why it obviously holds. Okay, now let me go to the second part. On that case, it is very tough to deal with some x and pi x, so I should take something like this: a b plus a plus b plus a minus b whole square, and this is whole square. This is obviously equals to a plus b plus a square plus b square minus ab and its whole square. Now take it as x and take this term as y. Now apply AMGM inequality on x and y, which should give us x plus y greater than equals to 2 root over x plus xy, and hence we get x plus y whole square greater than equals to 4xy. Now it should be easy to note that a square plus b square minus ab is obviously greater than 0. If it has any problem, I will discuss this thing at the end of the problem. Let me give a star mark here so that I can remember at the end of the problem. Now, so what we get from this thing is very easy and obvious, that this is equals to 4 times x equals to a plus b and a square plus b square minus ab, which is actually equals to 4 of a cube plus b cube plus b cube. Now if we go back to the problem, we can see that the given condition is something like this: sum of x belongs to capital X such that x plus 1 whole square and pi x plus 1 whole square is equals to sum of our 8x cube, and where x belongs to x, and x is the permutation as I have mentioned previously. Now note that this is equals to 4x cube plus 4 pi of x and its cube. Why? Because this is permutation, and after summing, permutation does not change. That is why I can write it as following. We already get that x plus 1 square by x plus 1 square is strictly greater than equals to 4 of x cube plus pi of x cube. So their sum also follows this. Means if we put the sum sign here, because x and pi x both are non-negative reals, and hence x belongs to x, and similarly here also we put sum sign. So we our concern should be in the terms where the equality will occur. Now if we look through the inequality steps, we can see that we have make a inequality condition here, step 1, and we use another EGMO inequality that is here. So since we are concerned about equality case, we should get from step 1 is very easy, that pi of x minus x square equals to 1, and from the EGMO step it is very easy that a equals to b, a equals to b, not necessarily here the case is x equals to y, and which gives us that a plus b equals to a square plus b square minus ab. Remember that I put a as equals to x and b as pi x. So in which case we should look into is x minus pi x square equals to 1, and x square plus pi x square minus x times pi x equals to x plus pi x. Okay, now I should add minus x times pi x both side, minus x times pi x. So we get that 1 equals to x plus pi x minus x times pi x, and it's pretty obvious. From here we get that x minus 1 and pi x minus 1 equals to 0. Condition 1, when x equals to 1, let's say it as star, and either this is true or this is true. Both cannot be true, because if both are true then their difference will be 0, but we have obviously previously mentioned that our difference will be 1. So let me mark this case as double star. Okay, recall that we have get that x minus pi x whole square equals to 1, as we want to find equality cases. That is why we get that modulus of this value is actually equals to 1. Now this is the time for case bashing. We are now going for case star when x equals to 1. Now if x equals to 1, then pi x for some x can be either 0 or 1 or 2. Okay, so let me make a table here, x, and here is pi x. If we put x equals to 1, then pi x equals to 0. Similarly, x equals to 1, and this is equals to 0. And remember that x is its pi x is a permutation of x. So I put 1,010 1 here, 1,010 1 here, and here we put similarly 1,010 ones. It's 0 0 0 and so on. Okay, but look that this is not possible. Why? Because if this is possible, then we can see that x1 is equals to x2, but this is not in increasing order. So another case where we should look into is whenever we should put 1 here from the last and 0 from the first. And as I get previous, this is this is 1,010, and here is the number of 1 is 1,010. So in this case our permutation not, our x is actually equals to 0 0 0 up to 0. This is up to 1,010 terms, and 1 1, this is again up to 1,010th term. Now I have previously mentioned that there is another case when x equals to 1 and pi of x equals to 2. So let me put that stuff of things here. Again, x equals to 1 and pi of x equals to 2. X equals to 1, pi of x equals to 2. X equals to 1, pi of x equals to 2. And similarly, note again we should recall that pi x is permutation of x, hence we should get here 1 0 1 0 1, and we should inverse is like this, and here will we get 1 0 1 0 terms. Now it is obviously follows the condition given in the problem. So in this case x is something like this: 1 1 1 dot 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 1 2 2 and 2. Here we have get 1 0 1 0 ones and 1 0 1 0 twos. So we have get exactly 2. This is also not necessarily. We have get exactly 2 lists, namely these 2. Okay, now we should go forward to the second case. In this case we again look that second case. Our second case is pretty same, when pi x equals to 1 and we get x equals to either 0 or 2. To see why this is true, we should get that the previous things. Since pi x is a permutation of x, since the hence both case will be same. Okay,